Hello everyone. On this occasion, I will explain about my research entitled Detecting LLM-Generated Text in Computing Education, Comparative Study for ChatGPT Cases. I'm with Michael Sheinman, Carlos Aníbal Suárez, and also Michael Liut. Okay, first of all is the introduction. So we all know that misuse of AI chatbots with large language models, such as ChatGPT, is a trending threat in academic integrity. Students can complete exams or assessments with limited effort, resulting in questionable performance. AI responses are generated based on other people's textual data without proper acknowledgement. So usually, these kind of misuses are called plagiarism. So while checking students' work for plagiarism, instructors are often aided by automated detectors. A number of detectors have been developed to detect whether a work is a result of LLM or large language model. However, to the best of our knowledge, there are no empirical studies comparing the detectors in terms of effectiveness. So, as a contribution, we investigate LLM-generated text detectors and evaluate their effectiveness. So, for the method, we collected historical assignment data dating back to 2016 from two institutions. The data collected was from upper year undergraduate computer science and engineering students. We analyzed a total of 164 submissions. So 124 were submitted by humans, 30 were generated by ChatGPT, and 10 more were generated by ChatGPT and then altered using the Quillbot paraphrasing tool. So we compared them against 8 LLM-generated text detectors. The result in a total is about 1,312 prediction result. So the assessments analyzed in this study are taken from three undergrad courses: database, networking, and final project. For the final project, it is written in Spanish instead of English. Due to character limitations, data below 1,000 characters was excluded and data above 2,500 characters was truncated to the last complete sentence. This ensures the input data fits within the range of all detectors. LLM-generated text was created with the help of ChatGPT. The handouts were parsed and integrated with engineered prompts, removing irrelevant information like course code, deadlines, submission instruction, etc., ensuring it solely contained the core requirements of the task. These prompts were then fed into ChatGPT to generate a solution to the assignment. All of the detectors were tested in April 2023. So first of all, we need to discover LLM-generated text detectors. So these are discovered from January to February 2023 from social media, online use, and using previous literature on LLM-generated text detection. Public interest in LLM-generated text detectors followed the release of GPT-0, which went viral on January 2023. We found that some LLM-generated text detectors are likely to be replicas of open source work like GPT-2, and hence, we excluded such detectors from the study. So these are the detectors. We have 8 detectors, starting from GPT-2 output detector, GLTR, PoppyLeaks, GPT-0, AI text classifier, originality, GPT-Kit, and check for AI. You can see the links here. So now we'll discuss how we can measure the effectiveness of the detectors. So first of all, we have accuracy measured based on weighted averages. So basically, it is the average prediction of each detector across a dataset. And the second metric is, again, for accuracy, but it is based on threshold. So it is the proportion of correctly classified LLM-generated text. AI generated if the prediction is higher than 50%, or otherwise it is called not AI generated. The third metric is false positive. So original submissions that are suspected by LLM-generated text detectors. So we collected student submission before the release of ChatGPT. So it is obviously not generated by ChatGPT. And then measure their degree of originality with the detectors. Any suspected submissions, originality degree less than 50%, were considered to be false positives. The last metric is resilience. So we measure how good LLM-generated text detectors in removing disguises. So we paraphrase 10 ChatGPT submissions to Quillbot and measure the result. We employ the same accuracy metrics, basically, weighted averages and thresholds. So first of all is the accuracy result. Based on threshold, copy leaks to be the most accurate LLM-generated text detector with an accuracy of 97%. Based on weighted average, the finding is somewhat similar, except the number is changed a bit. So from 97% to 99. And then we also see that Check for AI and GPT-2 output detector also have good performance. The next one is about false positive. So GPT-Kit is the only detector that managed to achieve no false positives across the entire set of human submissions. And then this is followed by other detectors like CopyLeaks with one false positive, GPT-2 output detector, or Check for AI with two, and OpenAI detector, Originality AI, GLTR, and finally GPT-0. So further investigation of GPT-Kit shows that although it has zero false positives, it is still prone to false positive. So while none of our original test samples appeared more than 50% fake, we found that some submissions score up to 37% fake from GPT-Kit. In some cases, removing the last paragraphs from these submissions led to false positive. The next one is resilience. So the GLTR detector was the most resilient with none of the predictions changing. It is worth noting that the overall weighted result of GLTR also decreased by 10%, although the change did not affect the accuracy. In contrast, the rest of the detectors saw a significant drop following the transformation of Quillbot. There is a case at which ChatGPT data went from 98% to 5% after Quillbot transformation. And the next one is the finding from Spanish dataset. So CopyLeaks and AI text classifier tend to always output fake predictions on AI data. In contrast, GPT-2 output detector, GPT-0, Check for AI, GLTR, and GPT-Kit, and then originality tend to output correct predictions. And next, we will discuss our experience of using the LLM-generated text detectors. In general, many LLM-generated text detectors are intuitive to use, similar with many online similarity detectors for identifying text plagiarism. They have a web-based interface where a user can paste their text they want to check its originality. GPT-0 and Check for NI allow their users to upload a document instead. While there are a number of LLM-generated text detectors, only two of them have the technical reports publicly available. They are GPT-2 output detector and GLTR. Technical reports might be misused by some individuals to trick the detectors. And again, we know that some detectors are commercial. Most LLM-generated text detectors do not facilitate API integration. GPT-0, GPT-Kit, Originality AI, CopyLeaks provide such a feature, but with a fee. Without API integration, it is quite challenging to integrate detectors to existing teaching environments, especially the learning management system. LLM-generated text detectors are unlikely to be independently used as the task is labor-intensive. As many of the detectors are commercial, their code is not publicly available, making it difficult for instructors who need a customized tool that suits their needs. The only open source detectors are GPT-2 output detection and DLTR. The detectors are also available but limited in terms of input formats that they support. Most of them only allow raw text pasted in a form, making them difficult to automate. The PDF parsers that we attempted to use often parsed in an incorrect order and had the tendency to include unwanted characters. We had to write custom scripts to parse the text in a format that translates all information to text. The next one, we found that detection results are challenging to interpret. Detectors attempt to combat this problem by highlighting content that is more likely to be AI generated, but yeah, it is still difficult to understand. The highlighted content can be at word level, sentence level, or even paragraph level. GPT-2 detector and AI text classifier are two detectors without the highlighting feature. While highlighting does not seem to be helpful, um, why? Because first of all, this was particularly evident with GPT-0, which highlighted 52 human submissions as either possibly or entirely AI generated. It is unclear what makes the highlighted text more likely to be written by AI than the other sentences. In terms of output quality, it seems that detectors are limited in their ability to export results. However, some detectors are more effective than others. Most LLM-generated text detectors only support English as the language of LLM-generated text. While one can still send text in other languages, the results do not appear meaningful as we previously showed. As many LLM-generated text detectors are commercial and they are relatively new, they appear to have most individual pricing. GPT-0, copy leaks, for instance, have business pricing. And they can be like less useful for instructors living in countries with weak currency, as the prices are usually in USD. So as the discussion, the current state of LLM-generated text detectors in 2023 suggests that they are not ready to be trusted blindly for academic integrity purposes, or as reliable plagiarism detectors, such as Turnitin. At first glance, it appears that the detectors are fairly accurate. However, upon deeper inspection, it is apparent that the number of potential false positives can lead to a wide array of issues, especially if being trusted for plagiarism detection at educational institutions. Delving further, when a paraphraser like Quillbot is utilized, the average accuracy is substantially reduced. More than half of all cases cannot correctly be identified by these detectors. Though some detectors perform better than others, it is still a serious concern to use these detectors. Once non-English languages are introduced, these detectors are easily exacerbated. In terms of usability, LLM-generated text detectors need some improvement, and they appear to lack in understandability. So, as a conclusion, this paper examines 8 LLM-generated text detectors' effectiveness. While detectors manage to achieve reasonable accuracy, they are still prone to flaws and can be challenging to interpret. False positives are a significant concern, especially when used for plagiarism detector at educational institutions. When a paraphrasing tool like Quillbot is employed, the accuracy decreases. The detector struggles with non-English languages, resulting even lower accuracy. accuracy. So we have a number of limitations. It can be future work. Findings of the study reflect detector results that are accurate as April 2023. So maybe the findings might be changed now. And additional findings can be obtained by considering other effectiveness metrics. The findings might not be generalizable to other institutions, especially those with different operational languages. And while we believe that the data sets are sufficient to support our findings, we acknowledge that more data sets can strengthen findings. Thank you.